My name is Hari Radhakrishnan. I'm a physician at UT Houston, and I'm also started a company out of the software that we've written at the University of Texas at Houston, and that company that was formed is called Decisio Health. So I'll be talking about their product and how we kind of navigated the testing waters for the FDA. So the title of my talk is called Ascending the Summit, using Selenium to test web applications. So Summit is the internal project that we created to do our testing. And it was chosen because obviously you can climb to the top of the mountain, the summit, to achieve the highest level of quality with your software. But all of our applications, libraries internally use Texas names. So I'm a huge Rockets fan, so the Summit used to be where the Rockets played, and that's where that name came from. So my talk is going to be mostly about the approach that we took to test our application. You'll see our application here in a minute, and you'll see that it's somewhat different from a normal web application. We're not using request response model. This is all WebSocket driven. So the testing approach is a little bit different from what you would normally expect to see. So this is our approach to QA/QC. There's a lot of ways to skin that cat. So you just think about it from the standpoint of this is what we're doing. If you're interested in a different approach to QA/QC, Dakota Smith is giving a talk tomorrow at 10 a.m. So I would encourage you listen to his talk. He's got a very good approach as well. So we'll just talk a little bit about the FDA. The FDA is as you know, is the Food and Drug Administration, and so anything that's used for clinical care falls under the FDA regulations. So whether it's a device that goes in your mouth or software. So if you think about it this way, popsicle stick goes in your mouth. It's not used for clinical care, not regulated. Tongue depressor, it's probably made by the same company, goes in your mouth, used for clinical care, FDA regulated. So it's a very bizarre process. They're a very strange organization. What they look at for testing is different from what we would think from a logical standpoint. And so even though software doesn't touch a patient, we don't administer medication or anything like that, they still consider it a medical device, and so you have to get it cleared. And they also don't have a sense of humor. If they don't like what you're doing, they're just going to shut you down. So if you've ever been to the website 23andMe, they were using genomic data and making clinical decisions about your medical history based on the genome that you sequence. FDA didn't like that, so they shut it down. So now they're ancestry off of your genome. And specifically, testing is a very important part of it. So you have to be able to convince them that your application is good. If you can't convince them of that, they probably won't clear it. So think about that when as we're talking here. So nothing that they subscribe to from the FDA perspective is outside of the realm of what you would do on any software application. They actually adopted IEEE and ISO standards for software testing. So what I'm telling you here is not just for medical devices or anything. It's just building good software and making sure that it's tested appropriately. And the good thing about testing is we've all been, worked with unmaintainable code at some point in our careers. This is the way that you make sure that your code works. There's always code out there that nobody wants to touch because it's too dangerous or whatever. So this is the kind of the way that you can iterate over your application and still maintain high quality. So what are the types of tests that you should be thinking about when you build an application? So unit tests and regression tests are individual units of code, usually at the function level, and it's usually written by the programmer who wrote the function itself. And the idea is that every iteration that you add new code to it, you still run the tests, make sure that they still work. So this is at at the Python level, you're writing tests to make sure that your new functions don't break old code. Integration testing is, kind of testing in between modules of your application. And then functional testing, which is what we're going to talk about more today, is tests based on your software specification. So it's very important that you understand when you write an application, you have to have requirements. What is your software supposed to do? If you don't have requirements, then you're just going to kind of smear, feces on a piece of, on the screen, and then people are just not going to like your application. So especially in medicine, doctors are very angry people. They don't like applications that don't do what they want them to do. So it's very critical that you, get your requirements in place so that you know what to test against. Then another important point about this is if you don't document it, it didn't happen. So this is coming from as a physician, you see this, if I do a procedure on a patient, or from a medical legal standpoint, if I don't document it, it didn't happen. Well, it's really true everywhere, right? If you test something, you need to know, and so you need to let everybody else who knows that it was tested. And you need to have an audit trail. And why is that important? Well, when you build an open source library or you sell your company, somebody wants to know that it was tested. And this is one of those things that if it may be just checking the box for some people, but you can check that box, people get, are okay, they can, proceed. There are a lot of companies that have, go through due diligence and they decline to purchase the company because of a poor, quality of code or lack of testing or documentation. All right, so what is the software lifecycle with good testing? Well, so you gather requirements from the customer or the end user, implement those requirements, test those requirements, and like I said, you need to know what you're testing. So feature creep starts in applications when people don't just start building things that they think are cool. Oftentimes, it's harder to take stuff out than it is to put stuff in, and that's what ends up happening. You see it in all kinds of applications, Microsoft Word. You can, there's a kitchen sink in the application, and it ends up causing problems because there's so many things there that it becomes hard to maintain and use. And then ultimately, you're going to have to ship your software and then collect underpants, ... profit. So I don't know if you've ever seen the South Park episode with the underpants gnomes. That's the reference there. So this is our actual submission. It was 4 months, 700 pages of documentation. Each one of these represents one copy. 2 went to the FDA, 1 to our consultant, and 1 kept to us. So we did this in record time, and we were actually praised by the FDA for our testing, which is something that doesn't happen. The guy went out of his way to tell us that we tested better than most people. So it's important that, that your testing is able to be, documented and somebody will pay attention at some point. And then we have to be mindful of what we're doing. This is our application running in the ICU. This is a trauma patient, as a femur fracture, liver injury, head injury. This application is taking care of people, right? At the end of the day, the quality of our application is dependent on, and people rely on this. If we screw it up, yes, we're not going to directly harm somebody, but we can mess up we can mess somebody up because they can act upon data that we provide to the patient or to the bedside physician. So just a little demo of our application so you can understand before we dive into the Python. Can everybody see that? Okay. So what you're looking at here is a 24-bed ICU. This is a simulated data set, so you're not seeing real live data because the privacy officer would have a heart attack. But this is a simple screen where you can see who's in the unit, name, what we call these bundles of care, which are calculations that are run in on the patients as the data comes through, and then we populate visual alarms for the physicians to see. So and then we also have real-time vitals on the right here. So you're probably thinking, well, isn't this something that exists in the medical record or and so forth? The fact is it doesn't. People haven't put up monitors like this in the ICU. It's a very novel thing for a lot of physicians because they end up spending an hour, hour and a half looking at data, collecting it, writing it out on paper, and then going and taking care of their patient. So, and this is running inside the patient's room, so you can see it as you walk in. And so what we have here is the actual display of that's in the bedside and that you saw at on the pictures. So the data is fed through our system. It's processed from all the data that comes through the medical record, and we populate a dashboard that you're seeing here. And this is also available on your phone or your tablet or whatever. But the important thing here is that this is a different kind of application. We're not doing a request response model. Nobody's sitting here refreshing the page. So we're pumping data into the system and it's being pushed, and these are up for weeks at a time. So we have to test a lot of different things. So does the data that gets pushed in come out on the other end? Does it get formatted correctly? Does it get colored correctly? So this stoplight system that you're seeing here with the red, yellow, and green is an indicator of what's being calculated on the system and displayed. And so the display itself has numerous layouts, and so we have to be able to test all of these different combinations of things. And so this is from a testing perspective, there's a lot of things that we have to look at here. And we also have to, since this is live running 24/7, we have to be able to ensure that the system works when things break. And so what happens when the system goes offline? And so those kind of tests have to be brought into the system as well. Anybody have any questions about the demo?
So in your application, it looks like the use of red, green, and yellow is reserved for specific, like that can only mean like this is, we're sending information, this is good or bad.
Correct.
So anything, you can't use those colors except for that purpose?
Right, and so the blue is the neutral color on the screen, and it used to be white, but there was a contrast issue in the ICU. So we switched to this darker or lighter blue color to help with the contrast on the screen. Anybody else?
So what is the underlying stack of it?
So let me show you that here.
Question, you said you deal with failures. What happens if power fails? Would the doctor to have a backup?
Well, so the backup is always the medical record, right? But it's not at the bedside, so they have to leave the room, go and look. And when you're in an emergency situation, you need information, right? This value right here is the potassium. So if you're trying to put a tube in somebody to help them breathe, if their potassium is too high, certain medications will elevate that, could kill them. So, emergency situation, they need to know what's available. So this is the way that they can get that information at the bedside. Let me see here, get to the stack. So this is our stack. This is a part of our FDA documentation. I'm sorry, that's a little small. But essentially the data comes in from the medical record, goes into a pipeline server. So this is a Tornado application that's that's using the multi-processing loop. And so data that comes in is pushed to us. So this is using a standard called HL7, which is a push notification system that we have to acknowledge. If we don't acknowledge, they queue up on the server. So this allows us to go offline with them being able to queue up the messages. And when we get online, they send rapidly. So that data is stored directly into Postgres. And then we use a notification system from Postgres to push that data to our database broker. And that database broker then pushes those to the broker clients, and the broker clients push that out to all of the listening devices. So this is a push system all the way from the EMR directly to the client. So whenever that data is processed, it gets pushed out. And so that could include any device. So we have to know if the device goes offline, that when it comes back online, it needs to request all of the data that it missed during when it was offline. So this, yeah.
Do you have to complete hardware footprint at every site installed?
From the server side?
Yeah, or do you have like a private, your company has your own data center?
So the problem is a lot of hospitals have either poor internet connection or they're HIPAA Nazis too afraid of things. So they tend to like having things in their own data center. Some hospitals don't want that. Smaller hospitals are okay with your. So I mean, from a privacy standpoint, it is Amazon will sign a business associates agreement, Rackspace, Firehose, all of these companies, and then at that point it's on them if there's a data breach. So
for an on-site, like does your company have to provide an operations engineer to?
We are almost done with the FDA process. The FDA process lets us sell. So what's currently running is a deployment by UT, and that's running on UT's data center, which is privately connected to Memorial Hermann. So these are questions that are going to be answered in the next couple of months for us. But for the most part, we're planning on putting an installation at every data center for every hospital. And so we also have a monitoring pipeline on the left here, which handles messages that are coming in to let us know if systems go offline, if we have exceptions, anything that comes through. So, the approach that we took was kind of build it ourselves. There's benefits to that. So there's obviously weaknesses to it, but we have full control over the system. Really, our only dependency is Postgres and some Python libraries. So we're not using any other data stores. So 20 minutes in, we're finally talking about actual testing. So we use Selenium. Selenium is a library that's written in Java. The website is seleniumhq.org. And essentially, Selenium's job is to, all of the browsers that are Internet Explorer, Firefox, Chrome, and Safari, and I guess Opera, all have a API that's built into the browser that you can connect to, and this is what Selenium does for you, is you can automate, and control the browser. So Selenium can be used for testing, but it's not just for testing. You can do whatever. If you want to scrape web pages with it, if you want to, you can essentially do anything. And you can do it across, different browser types, different versions. There's a company called Sauce Labs that lets you do testing as a service. So they'll provide you the infrastructure for all of the various browser types, Firefox, Chrome, etc., and for different OSs. So you can run Windows and so forth. When we went to the FDA, we initially said that we were only going to do WebKit-based browsers. The FDA didn't like that, so we went with just Chrome. So everything that's running on the bedside is either Chrome or Chromium, and we just have to go test to make sure everything works in Safari, which we already know it does, but we have to document it and test it. So that'll be forthcoming going forward.
While we're on Selenium,
Yeah.
were there decisions in your application that you made based on what Selenium doesn't do? I.e., like, I can't use Selenium to test this, therefore we cannot use this library or this feature?
No, I mean, it's the testing came fairly late in our process, and our application in the browser is actually using Ember. So the workarounds that we had to do with some of the Selenium stuff was I serialized the DOM, which I'll show you here, and use Beautiful Soup instead of Selenium because it didn't like Ember's. So Ember makes meta tags inside your HTML, which they've said that they're going to change out. But if you're using Angular and other web frameworks, they don't have that limitation. So we ended up serializing the DOM, extracting it out, putting it into Beautiful Soup, and then so that it does make our testing a little less efficient. We have to do time.sleep, which we'll talk about here in just a second. But the parts of our application, like the authorization system, are basically request response. So I was able to just use the Selenium libraries directly. So to do the testing, we actually used the unit test, Python's unit test library. So all of our testing classes derived directly from Python's unit test. And so if you've ever worked with the unit test library, it gives you two functions, setup and teardown, and those two functions allow you to run all your code inside for every test. So it'll be run before every test, and teardown will be run after every test. So let's see if we can. So, like I said here, we derive from unit test.testCase, and here is our setup function. So every test that we run, and I'll run here a couple here in a second, goes through this setup. So we create a patient's object. So we're going to create a patient, send data to it, check it on the screen, and then come back. We have a send message which sends the HL7 messages, and we take screenshots of our stuff. So we use an image counter. So there's nothing magical going on here. The one function that I'll give specific mention to is the Chrome driver function. So we just added a utility to pass in some parameters to get the Chrome driver, and we use that to. So you'll notice here when all of this is said and done, I use about 5 Selenium functions. We've used very little of Selenium's actual library because you don't really need much. You have to think about testing as you're writing code. Selenium is just, the last mile, to get to what you need to do. So don't think of Selenium as this massive library that you have to integrate 75 things with. It's fairly lightweight. There's a little, weirdness to it because it's a Java library, but it works very well. So the teardown function, which is right below. So like I said, we use the sleep function a lot in this part of our testing when we're testing the dashboard. This is part of it because of Ember's weirdness. So I don't like it, but we have to do it. We clear out all the pages who are there, or patients who are there. We close the driver, and then we delete the authorization for the patients. So, and then this discharge patients function just generates an discharge HL7 message and sends it out. All right.
What was this accomplishing in the teardown?
So before, so at the beginning of the teardown function, all the tests are still running. So I want to send the discharge message and let it wait a little bit before. I think
Before you continue?
Yeah, before I continue. So I just want to make.
Wait for your application to catch up?
Yeah, because there's going to be a lag time between the time that the message goes out and the time that it gets processed. And we're talking milliseconds. But sometimes if the data is coming in slower or the DOM hasn't rendered in correctly, I give it a generous amount of time. I could probably drop that down to 1 second and it would still work. Yeah.
So, correct me if I'm wrong, but I believe you can also run arbitrary JavaScript through that Chrome driver.
Yes, we do actually.
Perhaps even to do like a wait for a particular DOM element to come back, so that you could probably avoid having to go sleep at all.
So I'll say this, when I started this process, it was very early on, so I didn't know how to use things. And so, I mean, by all means, I'm open to fixing things on this. I will say that the second set of tests, when we did the auth system, I don't use any sleeps at all, so it's a lot more efficient. And I do. There are a couple of places where I use sleep because I'm turning off services on the back end, and that's the only time I really use it. So my goal for this week was to actually clean this all up, but got busy, so I apologize for that. So the WebDriver object. So you call here. I'll go to my utils function. So this is the Chrome driver function that we call, and you're going to notice when you do tests, you have a lot of boilerplate. So Python is dry. So make sure you're not going to see the pattern for the first 10 functions you write. You're not going to see the pattern, and then or maybe 5 or 3. Maybe I'm just slow, but you'll figure it out, and then you'll start writing the code to do this. So initially we were doing a lot of things with Chrome. Since everything we do is SSL, we had to ignore the certificate errors because we have a self-signed cert. But you have to pass it in a WebDriver path, which is there's a Chrome driver binary that allows you to connect to the Chrome thing, and it'll argue with you if you don't pass that in. Otherwise, we're just going to you can call driver.get, and driver will go to the URL just as you would expect. Let's see here. So this is the basic pattern for testing for what we had to do for all our tests. Get a Chrome driver, go to a URL, do something. So input, navigate to a page, do something on your back end. Find elements on your page. So this was, you can use the driver itself to do this, find element by ID, CSS selector, and class. That is largely what we used for everything. And like I said, I used Beautiful Soup in this, I'd serialize the DOM and then did it. But which I can. So this is our DOM code. So you were talking about sending JavaScript to the browser. We actually you can do that with execute script. It returns back the DOM, serializes it, and returns the soup back to us. This is one way of doing it. And like I said, I would prefer to not do this because it's, you're adding an extra library that you probably don't need. So we have to work on that aspect of it. And then essentially you're going to assert that the value that you expected is the value that you saw on the web page. So
But you have the parameters in wrong order.
what's that?
On your assert equal, isn't the standard like X unit format the expected value and then the value you actually got?
I mean, if that is a standard, then that's good to know. But I mean, it's asserting two equal, if two things are equal. So the WebDriver object also has a, so we can actually set the window size here when you're running your test. But there's also an implicit wait. So if you're actually calling a get or a find element by find underscore anything, you can set this implicit wait. So what it does is it will pull the DOM every so many milliseconds to see if that DOM object is ready, and then go. And so you only have to set this once per run through of your driver, and it will maintain that. And if after 5 seconds it hasn't found the object that it's looking for, it will throw an exception. So this is a great way to speed up your test because if you're writing a sleep, it is a hard sleep. You're going to sleep for 3 seconds, 5 seconds, whatever. This will wait up to 5 seconds. So if you know that there are going to be elements missing on your page as part of your testing, you probably don't want to use implicitly wait. You can also, there's an explicit wait, which I haven't implemented, but it essentially just pulls the system and throws an exception. So you can, or you can implement your own. So it's not doing much under the hood. And like I said, so time.sleep is not efficient, so we'll have to fix that on my end. All right, so we showed you the get Chrome driver. I have a screenshot utility. So the screenshot utility, what it does is it takes a snapshot of what exactly is in the browser. So you can use this, and we use it for our FDA documentation. So we would take snapshots throughout the course. So it's a very simple function. You just get screenshot as file, and I think it outputs PNG by default. And then we just increment the counter. So we pass in our test name so that it can output the file with the test name in it, just to make it easier for ourselves. So this check equality function is a special function. So one of the things that we're doing is not just automated browser testing. We're also checking if things were stored in the database and logged correctly. So we have two functions, check equality and check log. And so this function, what it does is it extracts data from the DOM and checks it against what it should be on the key. So we have these classes that exist at the top of our thing so that we know, for example, the heart rate or the sodium here will always appear in our DOM element as bmp.-sodium-current. And so we use that to extract the value. So this helper function does that for us. We just pass in the class. We use this class to namespace. Class name to namespace. And so it converts it into a camel case for us, and then we use that to measure. So we receive a camel case namespace value, convert it, class name, convert it to the namespace, extract that off of the DOM, and then check the equality. So it makes it easy to look up the information. And then we check the log itself. Wrong file. So when the messages go through, as you saw on our flow, data flow, it comes into the log, into Postgres, and it gets saved. So this function essentially queries the Postgres directly, pulls out the message, and makes sure it was saved correctly. So that is the only hard data element that we cannot lose, is the messages from the hospital. Everything else can get reprocessed if we have to. So this is why we explicitly check this value. If you're not familiar, you can inspect your stack and know exactly what function you're in or what function called you. So inspect.stack13 will return back the calling function. And so why do we use that? Well, so in our test, so this base test dashboard is actually what runs the majority of our tests, and it finds out who's calling you, and then it sends it it sends that function name out to the test results, and that test results will populate our documentation. So the point of all of what I'm trying to show you about this is there's a lot of boilerplate code you're going to write, and the testing is, you're going to need to figure out how you want to test it and do your automated documentation. So we use all of these tools to basically do that. And we showed you class name and the namespace. And then finally, this outputs to an HTML or to a markdown file, which then gets processed. So you saw there was a test results function in there. That test results goes into this build context function. So when you call your test, which is test underscore something, it gets run by nose tests, and it calls this build context if you pass in the plugin flag. And it runs through this, and it actually generates a markdown file for us, and then outputs that through here. And I'll show you the output of that in just a second. So this is the output of that actual function. So you can see here that this is the message that we sent. This is the images that it snapshotted. So a blank screen, the lab came up. So I'll run that test and I'll show you that it does the exact same thing. Awesome. I must have typed something in my test file. So this is Selenium is actually running it. It admitted a patient, sends a message here, and then verifies that that message got processed. And then it sends me an OK. And all in that time, it's written this file out as well. So, and it actually we have all this documentation written elsewhere. It pulls it as it writes this out. So it sends an ADT message, goes to the index page, look at the dashboard, send a CBC, and then verify that they're correct. And then you can see on the output, these are the actual values that got sent. And this was what was sent, this is what's in the database, and this is what's on the dashboard. So we'll do one more test just to show you a So it's going to do a very similar thing. This time it's going to send a blood gas. It shows up at the bottom. It's going to send another blood gas of a different type, and then check that the second type overwrote the first type. So we have a lot of these tests because we have a lot of different types of messages because these were all part of the requirements of our application. So now if we want to do a test where we actually send send input to the system, which is how we authorize our users because they log in. We're going to run that test here. So what it's actually doing here is logging in, sending input to the system, logging out, making sure that the device got authorized. So this was all using implicit wait, so it was a much faster test. So I have to drag the test pops up on one screen, so I'm dragging it over. So you don't get to see the whole thing, but we'll show you what the actual code looks like. So the nice thing is now that I've gotten a little more experience with this, the tests actually look like something that somebody could write on a, and hand to me and say, this is how it needs to be tested. So create an account, go to a specific URL, provision a device, check that the device is provisioned, delete the device, make sure now you're back on the provision page, and then delete the account. So those tests look a lot cleaner than the tests that we wrote before, and a lot of that has to do with experience, I think, is number one, but also that we have a simpler setup here because this is more of a request response kind of test. And it may not have been obvious there, but we actually opened up two different browsers here. So we got a Chrome driver in our setup. We got the Chrome driver that is the device itself, and then the second Chrome driver is the auth driver. So we had two windows up. One to authorize the user, which is on the admin side, and one to actually go navigate the page. So you can open up as many of these as you need to, but just remember that they don't share data across. They have their own cache. So it runs the Chrome with the cache inside your temp folder. You get two completely isolated browsers. All right, let's see where we're all. So the way to send that is you have to select, which is that find element by CSS or ID, and then you call send keys and you pass in a string, and that's what gets sent to the browser. And then you call select element if you need to select from a dropdown. And so like we said, we just call get Chrome driver, use the additional driver to execute code, and then that driver can access data from the other browser. All right, so now, one of the tests that we had to do was turn off our system, so simulate a failure case, and then make sure it still works as intended. So let's... So it's logging in right now, created an account. It's going to authorize the device. And it actually turned off. You can see in the bottom corner here that the system is offline. So we actually used our Python to actually turn off the server. So which I'll show you here in a minute, we used Fabric and turned off the server. It came back online. It went back to the screen to show that there was data available. So we were able to manipulate the backend to actually do more than just regular browser testing. So this is, does the functionality still work when things break? And so let's go look at that test. So the steps that we're doing here are provision a device, turn off HL7 Web, which is our client, our broker client that sends us data. Go to the or retry the authentication because it should take you to the authorization screen again. Restart HL7 Web, wait 10 seconds. Now we wait 10 seconds because, explicitly here, because that's how long our browser actually takes, or our WebSocket takes to reconnect. So if it can't connect, it doesn't connect, try to connect except for every 10 seconds. And then retry the authentication and go back onto the page. So we can actually do that with Fabric. So Fabric is essentially connects and is used for automated deployments and things like that. It's a little bit raw, but you can also connect over SSH to your box, send it commands. So essentially what we did here was we called stop service, so stop HL7 Web and sleep for a second. And so that runs the stop command on the VM, which is running on my machine, turns it off, and that's how you saw it disconnect. May have been a little quick. And then we call start service again a little bit later. So you can see it here, execute stop service. We pass in the hosts, and the arguments for the function are the service type. And then we click to reauthorize and go back into the system. All right. So, questions? We're getting ready to ramp up here to sell our product. So we're always interested in talking to engineers who share our values, which are. Question? So. Mm-hmm. Right, so we have tests for those. The tests that, the layout change has been post-FDA clearance. So all of the tests that you're seeing are pre-clearance. So these are tests that are in my queue to write. The ones that I have written will do, layout changes. I'm changing the layout on my keyboard on the page. But ideally what will happen is the system actually detects what type of data it's seeing and then changes the layout for that type of patient. So if the patient has a head injury, it adds additional data elements like the ICP monitor. If it's a medicine patient, we may have a different layout. So the way it can test that is essentially it looks it up in the DOM. If it's not there, it throws an error. So it doesn't matter where it is on the screen. So for our testing purposes, so we can pull this because this is just class-based. So we haven't actually thought about doing testing based on specific places in this, on the screen. Right. I guess I misunderstood the question. Yeah, it's just using the CSS or the CSS class at this point. Yeah, so if you need to look us up there or have any questions, this is my email, and you can go visit our website. Go ahead.
Is code coverage part of the certification for the FDA?
Yes, so we submitted when we ran our unit tests, we submitted the code coverage for the unit tests. And so when we wrote the documents, we said we would have 100% coverage. Obviously, you can't have 100% coverage. So we had to write a deviation saying why we didn't cover some parts of our tests, our code.
Can you just test like each widget, or you have to test each widget in every layout that you offer in your application?
So the other thing about the FDA is that if you can convince them that the world is flat, they will accept that the world is flat. So you have to, if you convince them that we want to test it based not on layout and just that the data element appears when it's supposed to, they're okay with that, as long as you give justification for it. And so, there's benefit to testing the layout to make sure it looks correct and stuff like that. We didn't pursue that, so.
And then specifically with the heartbeat monitor, like, do you have to, like, how do you test that animation is at the speed that it actually is? It's like, you just don't.
We don't. And
That's not something you have to guarantee.
yeah, it's been a point of contention. Some people really like it, some people really hate it. So, I think in one of the versions that you see here, it's much smaller. It does beat in time, as part of the CSS, it renders that way, but yeah.
Does it make the same sound as it does in Star Trek? But,
That's a good plan. We should have that.
How big, your software makes some medical decisions, right? With get an alert or something. How big is that piece of code compared to all the factors, the database and tests?
It's very small.
Very small.
Yeah.
How do you test that part of the medical part of it, not the?
So we'll send it different inputs. So you saw this bundle here, the sepsis bundle. So this takes 4 or 5 different parameters, heart rate, blood pressure, white blood cell count, and so forth, and uses those as an output. So we send all combinations of it as a test, make sure it colors correctly. We also have unit tests for those as well. So the functional part of it is to make sure the color comes in correctly, the sepsis score is correct, and so forth. Anything else?
slides and or code available.
The code will not be available, unfortunately, but I can make the slides available.
So is it not a standard implementation for Selenium using execute test in Python? Or not, like the unit test? It looks like you wrote your own class for that.
Yes. When you listen to Dakota's talk tomorrow, if you're still interested in that, he uses the page object model, which is some guy wrote a library that uses that kind of setup. And I'll butcher anything, so I'm not going to say any more. You just have to hear what he has to say. I'm the kind of guy who just, because I didn't know how it worked, I just wanted to see. So I'm open to trying if a library works, it makes it better. But you can see there's very little actual Selenium code in there. It's mostly our stuff to make things, tested. So. All right, I think my time's up. So you can come find me. I'll be here the rest of the day. So.